talking about when you ask it in that way, what you're looking for.
Yeah. So if I give you a problem like this here, ask you to find x and y intercepts. How do you find the x-intercept?
Plug in 0.
Yeah, make y equal to 0. If you force y to be 0, that means it's got to be somewhere on the x-axis. So I like to think of it as you're interrogating this equation. That's what math people do. They come up with these weird-ass examples. So when you put a y equals 0 in there, you're forcing it to tell you where the hell it is. And y equals, where are you when y equals 0? So then you throw in there y equals 0. That piece goes away. Divide by 6. So your y-intercept would be 9, 0. Cool. And then do the same thing for the y-intercept. You make x 0. Divide by -9 equal y equals -6. Just plot those and connect them. Yeah. Yeah.
What if you forgot you do it like that and slope intercept?
That's what I do.
So that would be, you're going to lose some points.
That's exactly what I did. That's why I asked that.
So I can't take off a ton of points because that's something you have to be able to do. But I specifically want to make sure that everybody can find the intercepts. Especially if that's the only thing you need, you don't need to graph it. You wouldn't waste the time putting it in the y-intercept, slope-intercept form. You would just throw zeros in and get it, right? So I need you to know how to do just this. And then I went one step further and said, okay, go ahead and graph those points and connect them up. So, I mean, if you did that, you're not going to lose a ton of points. You're going to lose something. Because you didn't find the intercepts first and then graph. Yeah.
If you ask that, then you would just do the y equals mx plus b? Is that, like, what did they do?
His question would be like the last question. If I would have said, find the slope and y-intercept and then graph.
Yeah.
That would have been beautiful.
We use the graph to give us the points.
Yeah, and I asked for get the points and then make the graph. So you gotta, be careful. Yeah.
So if it's already in like y equals mx plus b, you could just fold a b and then put 0.
Yeah, then if it's already here, it's already there, then you already know the y-intercept. There's no work to do. How do you get the x-intercept?
Plug in the 0 for the negative.
Set y equal to 0. So you get 0 equals 4x minus 2. And then solve for x. Right? No matter what form the equation is in, when you make y 0, you solve for the x-intercept. When you make x 0, you can solve for the y-intercept. I don't care what form it's in. But the nice thing, if it's in this form, you know the y-intercept. But this form doesn't help you with anything except that. In this case, I want the intercepts. So why would I even, like this one, I wouldn't solve for y. That's extra work. I just throw zeros in and get the x, y intercepts.
If you don't put 0, -2, say if you just put -2 as the y-intercept, will you lose some points to that?
I don't know. I got to think about it. I try to make a big point of that, so I might end up taking a point off for that, just to make the point.
And then the one where you're plugging in zeros for x or y or whatever. So you just need to plot those 2 points. You don't need to do a third one, because I know usually, like you say, like if you have a table of x and y or whatever, you plot usually like 3 points. So just 2 is fine for that particular?
Yeah, 2 is all you really need, but you like that third point as a checkpoint.
Yeah.
You can always have a third point as a checkpoint, but you really just need 2. Yeah. Crappy thing is if you do the third point as a checkpoint, you mess up that, and you think the other things are wrong when they're fine. That's when things really suck. Okay, cool. Anything else? Okay. Anything from chapter 4 homework? Yeah. 4.4 number 9. This is a perfect little review. Number 9 says, as part of a fundraiser, the Cobble Hill Daycare. This is page 266. They collected 430 returnable bottles and cans. Some worth 5 cents and some 10 cents. If the total value of the cans and bottles was $26.20, how many of each did they actually collect? How many 5-cent bottles? How many 10-cent bottles? So where do I need to start in this? Good. I need to start my variables. This is just this is a word problem. This is a word problem where I can use 2 variables to solve it, but I still have to start there. I got to start with what the hell are my variables? Hold on. Let's take one step back.
F and T.
F representing 5-cent bottles,
T for 10.
and T for 10. Sounds like what I would do. Cool. So what's one equation going to be? Remembering what we said last time about you almost always have an easy equation, the total equation.
F plus T equals 10.
Yeah, the number of 5 cent plus the number of 10 cent has to be the... Now, what people always do is they try to bring this idea in here, but this is number of bottles, not money. There should be no money here, no money there, because there's no money there. Ain't no money nowhere. And the second equation, I'm going to have all my money. And here's where you got to be a little careful how you write it up. Yeah, you either make everything in terms of dollars. 5 cents is how many dollars?
0.05.
Yeah, 0.05. Or you make everything in terms of cents. $26.20 is 2,620 cents. Right? Either way. But you can't mix and match. So personally, I would rather go 5 cents per 5 cent bottle, 10 cents per 10 cent bottle equals 2,620 cents total. Then I don't have to worry about any decimal stuff. You with me? The biggest mistake I see is people doing that, and then it doesn't make any damn sense. You get some funky, you had 1/7 of a bottle, you broke it and lost it in here. I got 1/7 of it. No, okay. No, that's not good. They're not going to take that. So make sure that cents, or if it's dollars, you got to have 0.05, 0.10, 26.20. You guys see that point? That's a very easy point to miss. Now that you got these set up, you can just attack it with elimination, substitution, whatever the hell you want to do. Yeah, if you want to do substitution, what could you do here? Yeah, subtract t, so you get f equals 430 minus t, and then this you just plug in for f, right? That's the substitution method. If you like to do that method. Or I could take number 1 and multiply by -5 all the way through, and then that would eventually cancel with the f's there if I add those together. You guys understand at least one of those ways? You have to understand both eventually, because I'm going to ask you to do both.
I can't remember what we're supposed to do with number 2 to eliminate it.
So real quick, the substitution, let me do the first step on the substitution. You do this, and then you solve for t. Once you get t, you can plug it back in to get f. Right.
I'm thinking San Francisco by icing.
San Francisco.
Oh, 10T.
Oh, I see. There's no S's up here.
I'm teasing that. I knew that was a 5.
I got you.
But I really thought that's a 5.
So 5, yeah, rewriting this equation, 5 times f, but what's f? This. So 5f plus 10t equals 2620. I just plug in what f is. And the nice thing is now I only have t's to worry about. I can solve for t. Yeah, once you get t, you plug it back in, you get f. Okay, no big deal. If I wanted to do elimination, Like we said, you should take number 1 and multiply by -5. And here, let me say this. I always see that, always see this, and I always forget to say something about it. That's right. This is the kind of thing I get on the next step here. Everybody figure out what somebody did there.
It's just
Hopefully that looks wrong to most of us.
Subtract it from the second one.
Do you see what I see people think that those go away only if you add them together. So you got to add everything else together. See, all they did was they made those go away, and suddenly that's an equation. Do you guys see that? All right, good. Don't start doing that if you haven't before. Just realize why that's wrong. It won't cancel unless I actually add them together. So that plus that is 0. 10t minus 5t, positive 5t. 2620 minus 2150. 470. Cool. Do you guys, is that cool? You can't just touch the equations together and those parts pop like a bubble. Yay! You have to actually add them together and then those two go away. So here you just divide by 5. Once you get your t, you can plug it back in to get f. And no matter which way you do it, you have to come out to the same answer. All right, it's just one answer for this thing. You guys semi with me?
so that you get a fraction for f.
So let's see what we get. 5 goes into 470.
94 times.
And when you plug it in, f plus t
430 minus 9.
equals 430, and then you just subtract 94.
336 divided by
No.
5.
F is 336.
But the total number is 430
Totally.
cans.
So if t is 94, you do 430 minus 94 to see how many f. And you're done. You could use this equation if you want to, but then you have to plug it in here. 94 goes in here, subtract that, divide by 5 at the end. But I'm using this equation, right? Why am I using that one? Because it's the easier one.
That doesn't add up. They're like 336 plus 94. Never mind.
So don't bring that one in because I'm not using that one. If I did, I better get the same answer.
Okay.
But I would not use that one because that one's got smaller numbers. Not a damn thing wrong with that. Anybody notice that this equation can actually reduce it? Can't you divide everything by 5? It's not a bad first step, but it's just quicker to tell you honestly to multiply the element by 5. What the hell? It's already kind of set up for elimination. But do you guys see how that 5 goes in each one of those? Then you have f and f. You just have to multiply through by negative and kill the f's that way. Maybe. Yeah.
So you subtract 2620 from 430, right?
No. So here's my two equations for the problem. I took the first one and multiplied by -5. And then I added these together. Are you talking about what I did down here?
No. Where you got the point negative
Multiply this by -5.
It looks like you're doing X minus 5.
Oh, I see. Times -5. I don't know. Yeah. Right. And I multiply this by -5 just so that it matches up with this +5, so they'll kill each other.
That was the elimination.
That's elimination, yeah. Because if I add them together right now, nothing cancels, so it's no good. I'm not going to add them together. Yeah.
So I did it the opposite way, and I multiplied everything by 10. So I got 336 first, and then I
love it.
430. That's fine.
Sweet. Because if you multiply by -10, you kill the t,
Right.
and so you'll solve for f first.
Right.
And of course, you have to get 336. Yeah. Because it's, no matter which way you attack it, it's got to come out to the same number. Okay, cool. So obviously, if I got like a 0.9 somewhere, it doesn't make any damn sense, right? If you break your bottle, you ain't going to turn it in, sorry. If I get a -3, did you steal 3 bottles from the recycling center? That's not really a good thing to do, right? Do you understand what I'm saying? I mean, I'm trying to show you, if you did something wrong and you get a negative number and you don't have time to go back, I'm like, give me your papers, get out of here. Then you write real quick. I'm not sure why it's negative, but it shouldn't be. Say something. Don't just leave it. Negative sounds good. What the hell? Do you follow me? I mean, that's part of this is not only understanding how to do the math, but part of this is understanding what the hell it means at the end. If you give me a negative number for number of bottles you gave to somebody, what the hell does that mean? That doesn't physically make any damn sense. You're like the bottle black hole. Any bottles do. I don't know what that means. Okay. Sorry. All right. All right. So is that cool? Any other questions on that one? Okay, that's enough of that one. Anything else from the homework? Yeah. So let me help you set this up, and then I'm going to leave the rest of it to solve for everybody at home. Spice of life. So ground sumac, they sell it for $1.35 per ounce. And ground thyme, they sell for $1.85 per ounce. Iman wants to make a 20-ounce za'atar seasoning blend using the two spices that sells for $1.65, blah, blah, blah. So, I mean, if I blend these together, you can look at this in a couple different ways, but that's some more expensive stuff. So if I put some of this stuff in it, it's going to take the price down a little bit. I'm going to be diluting it, right? Like they do with the gas. Put some water in there and dilute it a little bit. Great. So it kind of makes sense that if I'm going to blend these together, the price should come out in between these two. So his price, he wants it to be $1.65. That makes sense. Yes, sir.
Wouldn't you just add them and then
Keep going. Divide by 2?
yeah, that?
I love it. It would be great if I want to use the same amount of each. In which case, the price would be the average of these. Is the price the average of these $1.65? Is that right in the middle of these two? No. So I don't have the same amount of each. I love that. There's a whole lot of kind of analyzation that can go on with these kind of problems just to kind of get a better feel for what the hell's going on. I want to mix these and end up with $1.65. You with me? Can anybody tell me which one of these I'm going to have more of in my mixture? The time. Why? How far away from this price is that? 30 cents. How far from this price? It's closer to this one. So if I have a thing full of thyme, if I could put thyme in a bottle, if I had a thing full of thyme, and I just put like a little bit, sprinkle some sumac in there, it's gonna be like $1.84 now or something. You with me? I'm gonna barely dilute it. So the more sumac I put in, the lower the price is gonna go. Does that make sense? If it's pure thyme, oh yeah, this is pure thyme, then that's gonna be $1.85. The minute I am diluting it with something else, it's going to decrease that price. I only took it down by 20 cents. I didn't even get halfway. If it was halfway in between these two, I'd have the same amount of each. I must have more time because it's closer to the time price, yeah.
Why did you start with time instead of sumac?
I didn't have to, you're right. I could have done it the other way.
So then you would have 1 complete ounce of sumac at $1.35. That's your starting point. Then that would mean that you would have less time because it would be a lesser amount, or actually a little bit more of an amount that makes that difference.
I'd have to have more time, no matter which way you look at it. I mean, if I start with the sumac, and I'm sprinkling thyme in there, I'd have to sprinkle in the same amount just to get it to be the average of these two. I really want you guys to understand. At the same time, I'm wrestling with this, because you don't have to understand what I'm trying to tell you right now to do this problem. But it's always nice to understand what's physically going on to make the math make more sense. So just suffer with me. Pretend to be looking at me if you want to zone out for a minute. If I start with a thing full of sumac, as I sprinkle more thyme in there, it's going to increase the price, right? So like putting more gold in my drink. Or gold flux. Somehow that's, oh yeah, more gold.
Increase the price of the sumac.
Say again?
Increase the price of the sumac.
Increase the price of the blend, the two together. exactly. So here's the sumac. I'm sprinkling some time in there. It's going to increase the price. If I put the same amount of sumac and time together, then the price would be the average of these two. And the average of these two is $1.60. If you average these two, you get $1.60. Isn't it $1.65? It's a little more expensive. So I must have put more of this in than there is of this. So there must be more time in that thing. All right, now that whole discussion I just had with you, you can go report me to the authorities, whatever, was unnecessary to do the math.
You couldn't have put more sumac and made up the difference? I mean, it would have to be a lot more, but it would be...
No, the more of this you put in. If you pour more of this in, it's going to bring the price to $135.
Because it's just one out.
The more you put of this, it's going to bring the price more to $185. Are you with me?
It's like how drug dealers cut drugs.
I wasn't going to go there, but... I was actually considering that. Not that I've got an experience beyond watching shows on TV, but yeah, that's basically what I was saying. So when you pay a lot of money for your drugs,
It's more pure.
make sure it wasn't tough with something else less expensive.
All of a sudden everyone understands.
Thank you. All right. So when we got to the drugs way, let's just get back to that. So, all right. So now, how the hell you do the math here? So now we've suffered through the whole thing that I just talked about, and I'm hoping some of you guys kind of understand what I'm saying. Since it's higher than the average price, there must be more of the more expensive one. That's the bottom line of what I was just talking about. So how do I put this together? So I know I want to have, I think I left one thing out. 20 ounces, yeah. So he wants a mixture of 20, where the hell that came from? 20 ounces at $1.65. Okay. So what are the two unknowns here?
How much of each?
Yeah, how much of each? So I got the amount of sumac and the amount of time. Let's not call it S and T. Those are actually my two worst letters to use. So we'll call it, what we call it, Jeff? I don't know. X and Y. That's awesome. So now, how am I going to put this together? My first equation will almost always, not always, will almost always be very simple. What's got to be true about X and Y?
They equal 20.
They have to add to be 20. I have to have 20 ounces total of altogether after I mix them together. So my first equation, X plus Y equals 20. Now I bring in the idea of what? Money. Now I got my money equation is going to be next. So for every ounce of this, how much does it cost me? Yeah, $1.35 for every ounce of that, plus $1.85 for every ounce of that. Now here's where you got to be careful. How much total money will that end up being?
165.
Almost $1.65 per ounce, and how many ounces? 20 ounces. So you see how I have price per ounce times ounces. Price per ounce times ounces. Price per ounce times, I better not forget that dude. Right? I've got to make my equation consistent. It's got to have the same stuff on one side as it does on the other side. So the most common mistake is to forget that, and then you get some really, really funky answers. That's where you start getting onto negative amounts of sumac. You got your anti-sumac. And now I know it's filled with decimals and all that, but it's still the same idea. I can use substitution, I can use elimination to do that. So I'm going to let you guys finish that out. I did the hard part. With some of your help, we set up those equations.
Can you multiply the 1.65 times 20 first?
Hell yeah.
Okay.
I would highly suggest doing that. So I really didn't mean right now. It's just in your homework. So in your homework questions, think, right? Somebody asked me that, didn't they? Number 21? So any other questions from homework?
Yeah.
Yep.
Can you 2
Page 244, number 42.
Oh, yeah, okay. All right, so everybody got what they need here? So 42, this is page 245, 4.2. All right, this one, the difference between two numbers. So it says the difference between two numbers is 18. And then it says twice the smaller plus 3 times the larger, blah, 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 blah. So never forget, your real first step should be identifying in English what the hell's going on, and then translating that into math. So what do you want to call the smaller, the larger?
AB.
All right, let's try A, B.
What number did you say? I'm sorry.
42 and 42. So the very first equation question says, statement says, the difference between them is 18. Now here's where you got to be a little careful based on how you set them up. You can't say A minus B is 18. Can you guys see why not?
Because you don't know which one's bigger.
Yes, you do.
Yeah.
You totally do.
The larger, yeah.
You set it up to be this way, right?
Why can you say that?
Because how could the smaller number minus a bigger number be positive?
So B minus A.
So why did I have to be very careful here? Because the next thing they say references larger and smaller. I better know which one is which.
So it's B minus A.
So it's got to be, the first equation must be B minus A is 18. And then what's the second equation? It says twice the smaller plus 3 times the larger is 74. So twice the smaller, how do you say that?
2A.
Good. Twice the smaller plus 3 times the larger, 3B, is equals
74.
74. Cool. And again, substitution, elimination. You can even graph them if you wanted to. I'll suggest not to. Is that cool? So here, like at number 1, you can add the A over, then you can plug in what you get in the place of B. B equals 18 plus A. You can do substitution. You can multiply this by 2, because then those A's would cancel. I mean, you can do elimination. Whichever way you want to do it.
So in word problems, when they ask you to solve using a system of equations, every time there's a period, does that mean there's a new equation?
Not really. Normally in these problems, yeah, they pretty much follow the first thing and then the next equation is next, but I wouldn't say always. I would never say always. Never say always. Yep.
On the test, will you ask us to specifically solve an equation in a certain way, like by substitution,
Oh, yeah.
elimination?
Yeah. If I give you a word problem, I normally just let you do it whatever way you want to. But I'm going to ask you both, elimination, substitution, just so I can test to make sure you can do both ways. Because otherwise, somebody could forever do one and never do the other one. And I can't allow that. I've got to make sure you can do it both ways. Okay, cool. So we left off, we finished chapter 4, believe it or not. So we're getting into chapter 5. I'm gonna end up doing 5.1 and 5.2 together. So I'm gonna go through this semi-quickly because we should all kind of have seen some of these properties before, but certainly slow me down if I hit something that's a little weird. Let's start off with a basic idea of exponents. So Let me give you my little fake history lesson. That isn't too far off from the truth, really. Some dude or dudette had to write this down many, many, many times. Of course, if we're back far enough, it was probably a dude. So. If he wanted to write this down a lot, he's not going to want to keep writing all these freaking X's out. He's going to want to consolidate it somehow. So he said, let me just put a 5 in front of the thing, and that will tell everybody in the world that that's what that means. So I want you to realize that idea had to be invented, and then agreed upon, and then used. Everything we do in this class, at one point in time, wasn't the way it was done. It had to be, a lot of people did different things, and then we had to come up with a standard way of doing things. So 5 in front, we know that means 5 of these adding. So roughly the same time, on the other side of the earth, some dude has this. And he's like, damn. Took my idea. Shit. So I want to write the same idea. But I can't put a 5 out here. That would mean it's adding. And I want everybody to know it's different. So maybe I'll put it here. Now that just looks weird. Now it looks like division. Maybe that just is really, really weird. So just let me put it right there. What the hell? And now that notation would mean that I have 5 of those things multiplying. This is one reason why I love teaching that Math 120 class, even though I haven't done it in a few semesters, is we do talk about like Babylonian number system and Mayan number system, Egyptian number system, and all these different numbers, Chinese number system, ancient Chinese really, but all these different ways of doing math and just writing basic stuff like writing the number 2. How did the Mayans do it? How did the Egyptians do it? Just to show you that this is not somehow given to us by some god. This is us making it up. And then we just let everybody know. This is what it means. Oh, really? Okay, yeah. So that when I write that, everybody knows what it means. It's just a standard way of communicating. Now, the minute we're cool with this, the fact that math people are lazy, so they want a quick way to write this, all the properties come right off of that. So we got all these properties of exponents that always screw us up. But if you just remember, they all come from this idea. So the minute I say that this is the way it is, if I write this,
4 and 2.
yeah, because really, if I link of 5 x's, I can write as x to the 5th. Right? Link together by multiplication. This x squared is x times x. This x fourth is x times x times x times x. That's just from the definition, from the original idea. So if I link all those together, of course, now I got 6 of them in a chain. It's not x to the 8th, right? There is no 2. There is no 4. There is no 6 in this at all. There isn't. This 2 really just means 2 x's. And 4 x's to make 6 x's. Right? Cool. So what about if I have this? Beautiful, right? Because this means anything to the 4th power is that thing times itself. 4 times, right? So then you do 2, 4, 6, 8 using the first. So the shortcut is just multiply those. Right? The biggest mistake I see is people say that this is 2 to the 4th is 2 times 2 times 16, and they say the answer is x to the 16th. No. You only have 4 groups of 2. That's 8. That's a definition of multiplication, right? 4 groups of 2 things is 8 things. Okay. So what about division? Yeah. Because really, I never want to see you guys really do this unless you really have to get used to it. But you can write... And then 5 of them go away, and you're left with 3 of them. But please, dear God, see how that's just silly. If I have a link of 8 on top, and I divide out a link of 5, of course I got left a link of 3. So when you divide, you subtract. When you multiply, like bases, you add powers, right? That's kind of a nice analogy. Okay. So what about a 0 power?
So 1.
Something.
Just 1.
So let's use this property. Yes, and you're right, by the way. Don't freak out. I'm just going to show you why. All right. Let's use this property here to force a 0. So what would have to be up here to make this come out to be x to the 0 property? Think about this here. X to the 0 power. You have a 5 and a 5, right? They have to be the same number. So if I have x to the 5th over x to the 5th, that will be x to the 0. 5 minus 5 is 0. Think about what x to the 0 says. How many x's do you have?
1.
No. 1x would be this, wouldn't it? That tells me I have no x's. What happens to all the x's? They cancel, right? So that actually does say I have no x's. X to the 0 means I got none of them.
If you have to express it that way, you gotta 1 in that expression.
No.
0. Can you just go ahead and put 0 with the slash?
No, definitely not. That's not what that means. Because what is something divided by itself? 1. So anything to the 0 power is 1. Except 0, right? I just want to say that real quick.
How do you know that x is not 0?
Yeah, exactly. So whenever I write this, the same way when I write this, the minute I write this, I'm assuming x is not 0. In mathematics, we don't have to write that. It's assumed. The minute I write that, x can't be 0. So the minute I write this, x can't be 0. Because this thing is bad. This is actually called indeterminate. It's actually, I don't even know how to spell the damn thing anymore. It's something you run into in, I forget now where exactly you first run into it, Calc 2? Calculus 2. So don't worry about that. Your variables, basically, you're going to assume they're not 0. If they were 0, that would just freak the hell out. Right? So this is true for anything that's not 0. So what's, let me do an example here. What's 5 to the 0?
1.
1. What's negative 3 to the 0 like that?
1.
1. What's negative 3 to the 0 like that?
1.
No.
No.
What's that? What's 3 to the 0?
1.
With a negative on it.
Negative 1.
Negative 1.
Oh.
What's being raised to a 0 power here? The whole damn thing. What's being raised to a 0 power here? The 3. And what's in front of that thing? A negative sign. So that's the negative of 3 to the 0. So it's negative 1. And yes, I will put something exactly like that on the test. So be ready. So bring some more over here. One more of those. What would this be? It actually doesn't even matter what it is, tell you. What's the only thing not raised to a 0 power up here? X. So this x is actually understood to have a what here? 1, right? So this is x times 1. Cool. Minus 1. So anything to the 0 power is 1. And of course, any power can only go so far. We all know the example. Let's see if you guys do know this. This completely evil example, which is really what I did over there. Here, I'm squaring the negative 2. So what do I have 2 of? I have 2 of these,
4.
which is positive 4. Here I have 2 2's. So there'll be a negative sign with 2 2's. So powers are not very strong. They can only go that far. Parentheses help them catch the whole thing. If there are no parentheses, you can only get what it's right on top of. Hopeful. That will explain why some of you guys had trouble with this. Some people said that this was 16x. You see why that 2 is acting on the what? The x. And I don't even know what the hell x is, so I can't do shit with that. That's still 4x squared. I don't know what x is. It can't jump over there, right? 4 is to a what power? 1. Understood 1 up there. Cool. Yes, ma'am.
Why is that one only negative 2 times 2?
Because let's follow this through. There's a negative sign here, followed by 2 squared, which is 2 times 2. I don't have 2 negatives. like I did here. I have 2 negatives and 2 2's. Right? I have 2 of these. Here I have 2 of these with a negative outside.
So the parentheses isolates that number as a whole.
Exactly. Then this can apply to this whole thing, which is actually the next property. Ouch. Oh, let's see which property I'm on. 5. How are we doing? This should hopefully be mostly a review. Yes.
I'm not understanding the 0.
What about it?
I don't know,
Which part?
You will actually see that at some point is x to the 0.
Oh, hell yeah.
Because when it's not there, I just thought it meant there was just, I mean, obviously there's 1, that's what it says, but...
So watch this, watch this. What's the only thing that I can multiply x squared by and it stays x squared? 1. What do you get when you multiply x to the 0 times this?
3x3.
Yeah. Who said that?
0.
What's 0 plus 2?
2.
Because what do you do when you multiply like bases? You add the powers. You kind of with me?
So you don't convert it to the 1.
Alright, so you gotta be careful. You cannot say this is this. That's completely wrong. That's saying 0 is 1. Never said that. I said x to the 0 power. Anything to the 0 power is 1. Right? Now I'm trying to show you why that makes sense. We know the rule. When I multiply like bases, I add the exponents, right? X squared times x to the 4th is x to the 6th. You with me? So what's y to the 8th times y to the 0? Y to the what? 8. So multiplying by y to the 0 keeps it the same. What's the only thing that can do that? 1. So y to the 0, that's another way to kind of say y to the 0 must be 1. Because when I multiply something by it, it stays the same. Hopeful, hopeful. To me, though, I prefer this. I mean, this is very direct. When I subtract 5s, I get 0. Divide something by itself, you get 1. So this must be this. They're both equal to this guy. So they must be equal to each other. It's actually called the Transitive Theorem in mathematics. I always called it the duh theorem. Right? If I'm as old as you and you're as old as her, then I'm as old as she is. Duh. You guys kind of with me? Okay, maybe. So this equals that, so these two have to equal each other. That's a beautiful proof. But be careful, because I always get people, sort of like what you just said, I always get people replace this with this. That's not at all what I said. This is the number 1. No, this says no variables, no x's are there. So it can't suddenly become x. That's the exact opposite of what it says. Yeah.
So say if you had x with the 0 power plus, say, x with the 5th power, would that be 1 plus x to the 5th?
Yeah. Because x to the 0 is 1. Yeah. Okay. Oh. Alright. So the 5th property. Now that we've talked about all these different kind of things, and actually let me do one more before I get to the frequent one I was about to. What if I had this? It's sort of related to what we just talked about, the difference between -2 squared and -2 squared without the parentheses. What's being cubed here? Everything. So what's 2 cubed?
8.
8. Good. What's x cubed? X cubed. What do you do here? Careful. Multiply. So be really careful. This is addition. 2 y's in a row, 3 y's in a row, 5 y's in a row now. This is 3 groups of 2 y's. That's how you first learned multiplication a million years ago, right? Give or take a few. 3 groups of 2 y's is 6 y's. It's one of the easiest damn things to make a real quick mistake on. I make this freaking mistake every now and again, and it's just an awesome time when I do that. Right? So it's just, you got to be really force yourself to look out for that. I had somebody a long time ago, they were like, when you multiply, you add. Right? You guys with me? They had this whole other thing, and that's the only thing I can remember from it. When you multiply things, you add their exponents like that. Right? Maybe that'll stick in your head. I don't know. Yeah.
If the y square is not like 2 times 2 times 2 because it's cubed, y square.
Yeah, I'm not. Here I'm cubing 2. Here I'm cubing y squared. Cool. And in fact, what's the power on the 2? 1. So what would I do with the powers? 1 times 3 is 3. That's why it is 2 cubed. Because I multiply 1 by 3. If I raised this to that power, it would still be 1. The 2 would never change. Holy shit. Does that make sense? Is that cool? This is called, this should kind of sound familiar. This is called power distribution. And real quick, while I'm on that topic, remember how I started this whole thing with x plus x, let's just cut the 3, that's 3x, and x times x times x, that's x cubed. So coefficients are based on addition. They will play well with addition. So what do I mean by that? 3 times x plus 5. Don't I just distribute that in? You guys kind of with me? Exponents are based on multiplication. They will play well with multiplication. So when I have 5x cubed, I distribute that. Really nice analogy there. Since coefficients are based on addition, it can just distribute across. Exponents are based on multiplication, it can just distribute across. Yeah?
And if you had an exponent on 3 times x plus 5, when you do the exponent first?
You can't. That's the next step. So what happens with this thing? Exponents are not based on addition. These do not play well. This is where you have to write this damn thing 3 times and foil it and all this kind of crap.
Oh, okay, so it's like the next.
See, so when you apply an operation that is not based on the one you already have, it's going to be hard. But here, coefficients are based on addition. That's where they come from. That's why that's easy. This is easy because exponents are based on multiplication. Then that's easy. This one, oh shit. Yeah.
So would the answer to that one be 125x cubed?
I love it. And real quick, remember what a power means? It means I have 3 of these. So if you put 5x, 5x, 5x. Who's texting? What's 5 times 5 times 5? 5 cubed. What's x times x times x? X cubed. That's why this distributes. Because it's exactly what would happen. If some of you guys remember, that's how I showed you distribution. I wrote this thing 3 times and then added the parts together. So here, I wrote it 3 times and then put the parts together. And of course, 5 cubed is... Say again? 125. Good. You said it really excited. 125. Stop talking, John. All right, how are we doing there so far? Is that right? So this is called power distribution. Right? It's one of those words that make you sound drunk. Distribution. So finally,
What if the exponent is negative?
here we go. That's where we're going next. And then we'll take a break. And just to let you know, this is section 5.2. I don't know why they had to break it out from section 5.1, but they did. But it's the next thing on the list. Why the hell do that? So negative powers. How did I get a 0 power? Recall. We put x to the 5th over x to the 5th, and that got us 0, and that kind of proved to us that it equals 1. So if I want to investigate negative powers, if I have an x to the 4th up here, what do I want on the bottom? For example, anything bigger than 4, right? Wouldn't that force it to be negative when I subtract them? So let me put a 5 there, just because. So when you apply the simple property, when you divide, you subtract. 4 minus 5, negative 1. So let's look at this a different way now, just like we did earlier. Here I got 4 x's on the top. I got 5 x's on the bottom. How many cancel? 4. How many are left? Where?
on the bottom.
So this equals
1 over
1 over x. So what does a negative power mean? Flip. So let's investigate that a little bit more. Why does it mean that? Because it does. When I set up something that gives me a negative power, and I look at it a different way, it gives me the flip of that. Yes, ma'am?
So the bottom is always negative. The bottom
What?
part where the x5 is, that's always the negative.
If you were to bring it up, then it would be to the negative fifth. Is that what you're saying?
No, I'm just, like, how do you know it's negative 1? Like,
Well, no.
because they're both
What do you do?
positive.
What's x to the 8th divided by x to the 5th? X to the third. You subtract.
Oh, okay.
So here I'm just doing 4 minus 5 is negative 1.
Okay.
So we know that property is true. That you just subtract the powers. And then if I look at it a different way, I get a seemingly different thing, but that must mean that these are the same. So let's investigate that a little bit. What's the only way, let me see if you guys are cool with this. If I have 8x's there, what can you do to it? Well, what can you do to it? Let me try to force it in the direction. To make there be 7 now.
You pull one out.
You can divide by 1x. Are you with me? Let me put the little 1 up there. I normally wouldn't, but I just want to. Cool? Which, you know, I could also look at it like this. I don't know if I want to write it like that. Is that okay if I write it like that? Just pull it apart there. So, now,
What if you multiply negative 1?
look at you. So, what would I put here to end up having a 7? It's got to be negative 1. It's the only thing I'm going to add to 8 to make it 7. So, a negative power is effectively like dividing. Because I'm subtracting away the same way I do when I divide. Division subtracts powers. Negative powers, of course, is very direct subtracting the power. So this is the same thing as this. So what happened to this x to the negative 1? It flipped. These mean the same thing. Alright, so let's do a little more specific examples. Like, what's 3 to the negative 2? Careful.
The 9.
It's to a negative power, so the first thing I could do is flip it. So those two 3's are being raised to a negative power, so I can flip it. And what's 3 squared? 9. So what's 3 squared normally? It's normally 9. So what's 3 to the negative 2? 1/9. All a negative power means is flip.
Didn't you say that if the exponents are an even number, then they cancel the negative? Something like that?
The number is not negative. Is my number negative? No. My number is positive 3.
No, the exponent.
I know. But you're saying something about canceling a negative. I don't have a negative number.
She brought it down below and then you brought it back up.
Oh, sorry. 1 minute. My brain was stuck on 3 squared being 9. So yeah, of course, 1 over 3 squared would be 1 over 9. So 3 squared is 9. 3 to the negative 2 would be 1/9. What about, because what's negative power mean? Flip. Or reciprocate. Whichever way you like better, yeah.
Why can't you have a negative power? Then, like, you're not supposed to have a negative power ever.
No, it's you're not supposed to leave your answer
Yeah.
with a negative power. You can get negative powers all day long.
Yeah.
And if you do, you just flip it.
Yeah.
Yeah.
So if it was 5 to the negative third, it would just be 1 over 20, or 125.
Yeah, this would be 1 over 5 cubed, 1 over 125. Cool. Yep.
Did you show one where you actually brought the negative power back up after you were below the divider line? Just for me to do that.
To do what? I'm sorry?
So you had 3 to the negative 2. Right? And then you said, okay, well that's the same as 1 divided by 3 to the
Second.
power.
Okay.
Okay, and then you brought it back up, and you said, okay, these are 1, 9, he's positive 1, 9.
I didn't bring it back up. I want to make sure everybody understands. That 9 is still on the bottom.
Yeah, he's still there below the line.
Okay, good.
But can you show us one where if you flip that back up, you would be negative on top still?
There isn't one with negative on top, is there?
I don't understand. So, I don't get the idea.
So I think he's trying to say it's like reciprocated again, like take 3 side.
Or how could it be a negative?
Let me show you this. Let me show you this. What if it was 1 over 2 to the negative 2? It goes up. Right, so negative power means flip. And if you really want to get it silly, it doesn't like it up top. It's negative up top. So if you put it down below, it's happy. It's positive. This one doesn't like it on the bottom. So if you put it up top, it's happy. Right? So if you bring this up, what's that negative power mean? Flip it. So now it's 2 squared on the top with the 1 on the bottom. So that's just 4. Maybe. So 2 levels to this. I want you to understand really why negative power means flip. And I try to show that with how it acts like division, which means it would have to flip down to be the same thing so it can divide. It actually loses a power there the same way division would. So it kind of makes sense that a negative power would be related to flipping it. The second level of this is just realizing, now make that a process. Whenever I see something to a negative power, I can just take it to the other side. If it's down, I take it up. If it's up, I take it down. Yeah?
So let's say you got 3 to the negative squared times 3 to the 4. So we add a cross.
I love it. So if you had 3 to the negative 2 times 3 to the 4 like that,
Yeah, so it would be positive, right?
3 to the
Positive.
positive 2, which is just 9. Yeah.
Okay, so you wouldn't have to.
But if it comes out negative, then you have to.
If it comes out negative, so if I have 5 to the negative 11 times 5 to the 9th, what do you get? 5 to the
Negative squared. And then you
negative 2.
flip it, and it's 1 over
Good. 1 over 5 squared, which is 1 over
25.
25. Good.
So, and then you have to have the same basis if you were in the cross.
Yeah, you can't. Now, obviously, so again, if I have 5 squared times 3 cubed, can you make that 15 to the 6th? Or 5th in this case? I get that a lot. I get somebody tell me the answer is this, and I always say the same thing. I don't see any 15s, and you got 5 of them. How did you do that, right? So you can't combine these unless they're like bases. Because what's the whole idea? The power consolidates how many of each. So I got 2 5s and I got 3 3s. I can't put that together. You can say I got 5 numbers, but I need to be more specific than that for
So
people.
that would just be 25 times 9.
Yeah, then you could. The only thing you could do is 25 times 9, and then work it out. Yeah.
So like on the top one, you wouldn't do like negative 2 plus 4 and then 3 times 3 and get 9 to the second? You would, like I see how you did it like in 2 steps.
Yes.
So it wouldn't, like I probably would have done it, obviously it's wrong, but like 9, I would have got 9 to the second.
Oh, okay. Thank you. Don't freak it. You're not the only one out there that's thinking that thing. What's x squared times x to the 5th? X to the 7th.
Oh, okay. I see it now.
That's one
Yeah.
thing. That's one thing. Now her question is, if I saw 3 squared times 3 to the 5th, why is that not 9 to the 7th?
Because your 3s are already the same.
3s are already
You have
in
the
there.
groups of 3s. You don't have
I like it.
Yeah.
This, when I write exponents, that means I am not multiplying anything yet. I'm keeping track of how much I've got to multiply eventually. So if I had to multiply 2 3s, and somebody else came in and said, Johnson, here's 5 more 3s. Shit! So now I got to multiply the 2 3s already. The guy just came in and gave me 5 more freaking 3s. That should be 7 3s I've got to work with, right? I don't have any 9s yet. I haven't multiplied anything yet.
Right.
So that's what I was saying. This can't be 9. How did you get 7 9s from only 5 3s and 2 3s?
Right.
You can't. So that symbol, whatever that symbol is, will not change because the exponents are just keeping track of how many of those I've got. Really good question because I get a lot of that. My Math 105 students, I gave them a problem like this. Just gonna pick on them for a minute. And a lot of them told me the answer was 1 squared. Can we do better? 6 squared, right? 7 sixes, 5 sixes. So how many sixes do I have left? 2 sixes, which is 36. But a lot of people saying, well, the sixes cancel. No, they don't. I got 7 of them up here, and 5 of them now. You get left with 2 of them. You can't just kill that and say I'm done with it. No. Oh.
You get it.
Is that cool? So it's like my gang going back to the other. I got 5 people. They got 7. Oh shit. Well, there's gonna be 2 of them left at the end. Let's go. Right? It's a horrible example, but oh well. That's all I can come up with. What do we got today? We got drugs. We got gang warfare. Sounds about right. All right. You wanna take a break?
Yeah.
Oh, one more question, real quick.
Actually, the only thing I want to say is, like, you know how you said that the sixes would cancel? I'd say their way of playing is 5 of the 6s would cancel, and there'd be 2 left.
Yeah, that's what I hopefully said. I don't know.
Yeah, it's just like, I thought it'd be a little bit wording that way.
But what did I say?
Well, what did you say?
The mistake they made was they canceled the 6s directly.
Yeah.
Yeah, but of course,
Yeah.
you have more than just 1 6 of each. Yeah. Okay,
Exactly,
cool. All right, so let's take a break. Come back at 5 till.
That makes sense. So what people do is they think that the 6, it's like you know, it's like using like the way they count, like 1, 2, 3, 5, 6, but really it's like a group of that 6 is right. And another that's
Yep.
so there's still gonna be 2 groups of 6s.
Yeah, that first step was perfect.
So they're basically
5 minus 2. -3.
We're adding.
Now this is 5 minus 2 times the absolute value negative 3.
That would be nice.
So are you done with this here yet? So absolute values are like parentheses. They get done the very first thing. So this will be 5 minus 2 times, what is the absolute value negative 3? Of course, what do you do next? Subtraction or multiplication? There you go. Cool. Yeah.
I think what I was thinking is this. That would be a negative number, and that would be a positive.
Oh,
That's what
I got you. So if it was like that, I would agree with you. Of course, this, they're both negative.
Right.
Here I just got 3 2s and 4 2s, but they both have a negative.
You
Here I
have
have
3
3
negative
negatives.
2s and you have 4 negative 2s.
Here you do. There you don't. Here you got a negative sign with 3 2s after it. And here you got a negative sign with 4 2s after it. Whereas here you got 3 negatives. So yeah, you're right. 2 of them cancel, leaving with 1. Here you got 4 negatives, so it leaves you with a positive 16, right? 2 pairs kill each other.
That's
Yeah.
all that is.
But what I was worried about is I see, like people might think it's a square, so then the negative goes away or something. Or maybe it becomes a 1, I don't know. This can't act on itself. That's what I was worried you were saying. Right? Sometimes I'll see people do this. You see that? They flip the 2. You see what I'm saying? We don't even know what the hell fractional power means. It means something, but we don't know yet. But that can't act on itself. It can act on the thing it's on. I just want to make sure that wasn't what you were saying. Yeah, exactly.
Can I take the quiz?
You can't. But what will happen is the next test will take the place of this quiz. So you can have a copy of it. See what it looks like. Nope.
Okay, one more question. For D, I have to find the LCV.
Mm-hmm.
And I said it was 16, but like when I wrote it on the paper, but that just seemed wrong.
Yeah. It would work if you made them both 16, but that's not really the lowest, right?
Okay.
The lowest denominator would be the number that both of these can multiply up to be.
Mm-hmm.
This can multiply to be 8, 16, right, 24.
Mm-hmm.
This can multiply to be 4, 8. That's the first place they meet.
Oh.
So leave him alone and multiply this by 2.
Oh.
So whenever that you have 2 numbers and they have something in common,
Mm-hmm.
they both have a 4 in them, right? So this guy's got a 4 times 2, so all he's missing is that 2.
2. So then when I add the 2 over there,
Yeah, so now you multiply top and bottom by 2. So now you get 2 8s plus 3 8s. Right? 2 8s, 3 8s, 6. I know 8.
oh,
Sweet.
that's happy, right? No, that's not sweet.
Oh, and the corrections.
Yeah.
But I mean, if you made 16, it would still work. You should get 10 16ths, and then you have to reduce it.
Okay.
And then it would still be 5 8s. So I don't care what number, you can make them both become 80. Any number they both multiply up to be would work. What's best? LCD, so you have less work at the end.
Okay. That makes more sense.
Jeff, where do we put that?